Hello. Hola. Ese no. Hello, hello. Hola. 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 Welcome to Data Beers. Please take a seat. We need to leave the stairs clear. So all the people sitting in the stairs, you have room here to sit down. It's for our security and our safety. Thank you very much all for coming today to the new edition of Data Beers. Today we have, it's a slightly different Data Beers because it's a branded event by Airbus. They will give us a few words after in the small break that we do between the third and the fourth talk. So wait for it. They have a surprise for after beers. Can you please raise your hand if it's your first Data Beers? bad. So Data Beers always works in the same way everywhere in the world. We trick you for half an hour to drink beer. So that's the half an hour you have been waiting, drinking beer. Hopefully it worked. Now you are nicer, happier, and tipsier. Then we have the data story. So we will have today 5 speakers with very strict rules. They have to only 7 minutes long for a presentation, no code and no formulas. These are the strict rules of Data Beers, and it works everywhere in the same way. And then afterwards, we keep drinking beer. I leave the Airbus people to give the surprise where we're going afterwards.
So if any one of you have a story about data and you want to become a data science rockstar, just let us know, send an email to us, and maybe you are the next star in the next Data Beers.
Or if you know someone that is a data rockstar, please encourage that person to come and talk to us to someday be here and give a story.
Social strength.
So the organizers is Alex and myself today here. Then we also have Jose up in the door, Giovanna, Marcelo, and Ale that are not here with us today, but they are part of the organizing committee. So if you enjoy the event, high five to them. If you hate the event, high five to them.
So we are here in Data Beers Madrid, but Data Beers has been spreading around the world, and you can see all the places where Data Beers is happening. If any one of you know some people living outside, and any one of them is interested in organizing Data Beers there, please tell them and let us know also.
Because we can help you. So, and the help that we can offer is to get you 300 beers for free and then cool stories. So if you want to organize it in your hometown or somewhere that you live, please let us know and we'll help. We have all the material available and easy to share. It's very easy, so talk to us.
You know, this is a slightly different version from Data Beers, from the original Data Beers, which is called Braindead Events. This is not the first one. We have also been collaborating with BBVA, Telefonica, KPMG, and other organizations who are interested in telling the community the projects they are developing with their data, and also for creating a data culture inside their company. So if any one of you is in this case, also let us know.
So today we have 5 speakers. 2 of them has been selected by Airbus, and this is the advantage that they get for branding the event. The first one is Oscar, then Maggie Liu from ESA, Ares Aguilar from Cabify, Ana Laguna representing her mothership, Juan Carlos Pereira representing the University Carlos III de Madrid. So please, and a round of applause for them. So the first speaker tonight is Oscar Bach. He is coming representing Amblor. It's a company that is accelerated by Airbus, and they are sitting right in the building in front of us. They do an interesting data analysis for combining important data for a very important use case.
Okay, hello everyone. No? Oh. So hi everyone, I'm Oscar. We are Amblor. It's a startup from Barcelona. So what we want to do, we want to help to save lives in emergencies. How? Well, we want to participate, we want to help emergency services like police, firefighters, rescue teams, civil protection. So I'm going to explain you a little bit how it works, because from inside is not. Let's say here you have the emergency response chain. As you can see, there's the fire, for instance, an emergency. Somebody sees this fire and calls the 112. This 112 speaks with a dispatcher, which dispatches an emergency, like let's say firefighters from Madrid. They go there And in this situation, this is where Unblur takes action. So what is an incident commander, first of all? So you've got an emergency, and you see these firefighters trying to turn off fire. These are the tactical team. But above, you've got the incident commander, which is in the operations level and is the leader of an emergency. Is the one leading everything and taking all the decisions. What do? They do the incident evaluation, situation awareness. They get the awareness of what, like everything is happening. They do a risk assessment and the team coordination. So for that, they need data. They need data to take these decisions. This data needs to be relevant, real time, and updated. However, this information arrives incomplete, fragmented, and filtered, ending in saturation from this incident commander and with a coordination inefficiency. So we've also been doing a lot of interviews, more than 100 around Europe. 98% of the people interviewed think real data is a priority. 97% agrees that they are saturated, and less than 25% feel they have any tool to handle an emergency. So our solution, we want to create an intelligent assistant which will help taking decisions to these incident commanders in a safer way. So as you can see, what do we do to get this? So what we do is we integrate real-time information coming from helicopters, drones, body cams. They used to wear a camera here. All this information plus static data like geographical information, operational plans. What do we do? With this data, we integrate it, we process it, and we deliver it in a way they understand what's going on, so they can take these decisions. As you can see here is the first version we got. You see the map, you see all the resources, and you see all this the imaginary they get. We've been doing pilot sites, 12 pilot sites around Europe. I'm going to explain you the team. So we have 3 people in the business side and 2 data scientists, which are working very hard to get this. And this is the interesting part of the thing, of this event. So let me explain you. As you can see here, we have the data fusion we're doing with all these sources. Now we are in the prototype of the voice to text. So we want them to use technology, but imagine these incident commanders typing in a real emergency. That wouldn't be possible. So we've done a voice to text, which they just speak, and everything, all this data gets into the platform. With this, we can start analyzing to understand what's going on and to be able to be assisting them to take these decisions. So this is it. I don't know if you have any doubt. It would be amazing, you data scientists, if you could give us some advice in how to understand what's going on, because at the end, it's gonna save lives in real emergencies that nowadays happen. Thank you very much.
So we have time for questions after the most efficient talk in DataBears. So any questions for the speaker? Someone from the public with curiosity about how to save lives? Then thank you so much. Round of
Thank you.
applause. Thank you. Okay. Oh, sorry. So the next speaker is Maggie Liu. She's coming from the European Space Agency, and she's a cosmologist. and she's in DataBeers to explain us how data has helped her work using convolutional neural networks to model the cosmos. So thank you very much.
Thank you. Right, like he said, my name is Maggie Liu. I'm a research fellow at the European Space Agency. And on Twitter, you can find me as space_Mog. I tweet everything from data science, Bayesian statistics, machine learning, and in general, space and astronomy. And so let's jump right into it. I'm a cosmologist. That means I'm interested in understanding how the universe works. And it turns out that with our current understanding of astronomy, there's a theory, a standard theory of cosmology that describes the entire universe in just 6 numbers. That's right, 6 parameters can describe everything about our universe in the past, how it is in the present, and how it will evolve in the future. So will it continue expanding on forever and ever? Will it come to a stop? Or will it retract back and end up in another Big Bang? So the parameters that govern our universe are things like how much matter and hence how much gravity is there in our universe. Things like how much dark energy in the universe that is causing our universe to expand. And things like how fast our universe is expanding. So there's many ways to constrain these cosmological parameters, but the way I do it is through these objects here. These are galaxy clusters. They're the largest gravitationally bound objects in our entire universe. They consist hundreds, if not thousands, of galaxies all orbiting around each other. And 90% of their mass comes from the mysterious dark matter that doesn't emit any light at all. So if we look at the universe on the very largest scales, it looks something like this. You have all this filamentary structure, and galaxy clusters live and form in those densest regions of our universe, right in this big center here. And so as you can imagine, if there's a lot of dark energy in our universe, the faster the universe will be expanding, and so it's more difficult to form these galaxy clusters. And on the contrary, if there's a lot of dark matter in our universe, there's going to be a lot of gravity pulling these galaxy clusters to form, and hence they will also have a lot of mass. So to constrain these cosmological parameters, what we have to do is point a big telescope into the sky and count how many galaxy clusters there are as a function of their mass, so how heavy they are. And when you do that, you should get a function that looks sort of like this kind of curve. And the normalization of this curve and its slope is dependent on the cosmology that we put in. But this is not actually what we see. What we see is more something like this. And this is because we can't see the faintest galaxy clusters in our universe, even with the biggest and most sensitive telescopes. We miss those low mass galaxy clusters. So to do cosmology, all we have to do is be able to sample from this function. If we can generate galaxy cluster masses from this function, we should be able to constrain cosmology. But it turns out that this is quite difficult to see because this is what the halo mass function looks like. And I know I promised no equations, but this is very complicated, and this is the simplified form. If you write out the full theory, it's about 13 pages of physics. So you can imagine with all these integrals, it's very difficult and slow to do. So what we can do is go to Gaussian mixture models. So Gaussian mixture models are a way to decompose very complex functions like this one into more simpler forms, Gaussians, as we know. And if you decompose them into Gaussians and you sum these Gaussians up, then you can get this complicated function. But for our problem, that's not the end of it, because every time we sample from our cosmological parameters, our halo mass function will change. So this function is not going to be fixed. Knowing just the mean and the standard deviations of the Gaussians will change every time we sample a cosmological parameter. So what do we have to do? We have to go to machine learning, and not this type of machine learning, the helpful kind of machine learning. So with machine learning, what we want to do is we want to input some cosmological parameters, train a neural network. So you have a hidden layer, which is your cosmological parameters. They go through some hidden layers, which are like this artificial neuron, where you have weights and biases, and you want to spit out the Gaussian mixture components that make up your complicated function. And to get those parameters, what we need to do is do some training. So you can use this method as long as you can simulate from the complex function that you want to sample from. And this is exactly what I did. I generated 20,000 samples from my simulations, 8 Gaussian mixture components, 2 hidden layers, and 30 nodes. That's enough to simulate my 13 pages of theory. And so this is what it looks like. This is a selection function convolved with the cluster mass function. The blue is the true, and the dotted pink is the emulated from the Gaussian mixture model. And you see it fits pretty much perfectly. And you can test these on real toy simulations, which is what I did. I generated 500 odd galaxy clusters, and you see that the posteriors on these parameters are super smooth. But the important thing is, if you do it this way, you get a speed up of a factor of 1,000. And the accuracies are pretty good too. So the takeaway message from my talk is that in physics in general, we have a lot of complex theory. And by using mixture density networks, we can quickly speed up the process of generating samples from these simulations by using emulation and Gaussian and mixture density networks. So I work on Euclid at ESA, and this is a mission that's going to look at the dark universe in 2021. And Euclid will uncover hundreds and thousands of galaxy clusters. So hopefully I'm going to be able to apply this method when Euclid launches very soon. Thank you very much, and I'll leave it there.
Thank you, Maggie. Questions for Maggie?
Thanks for the presentation. So you tested in the simulation, right? I believe it was the Millennium or the Virgo simulation. Have you tried to apply this to, I don't know, Sloan or whatever, and see you get?
I haven't yet. I have my own data sample of galaxy clustered called XXL, extremely, extremely large. Just kidding. They're X-ray selected galaxy clusters, but I'm in the process of testing them on that to see what we get. But at the moment, we tend to work with very small samples of galaxy clusters, about 100 odd or so. And this means that we will have roughly 200 or so parameters to sample from. When Euclid launches, we'll have hundreds of thousands of galaxy clusters. So we can easily get like 20,000 parameters that we need to sample, and we really need this speed up to do cosmology.
You will only be using X-ray selected clusters, you said?
The only real way to select galaxy clusters is through their X-ray emission, because 10% of the mass of a galaxy cluster is in hot gas. And this is because the density is so high that you heat up the gas because of all the gravity pushing these objects together. And the only robust way to ensure that you have a galaxy cluster and not just random galaxies along your line of sight is to use X-rays.
Okay, thank you.
Thanks.
We have time for more questions. Someone else? Gonzalo.
Thank you for the talk. It was very interesting. Have you had the chance to visit our super telescopes in the Canary Islands?
Not yet. I've been to Chile twice, but not to the Canary Islands yet. Do you want to invite me?
I can't, but I advise you to go and check.
Someone else? I have one curiosity. Which programming language do you use to model galaxies?
Typically, I use R, but for the machine learning part, I'm using TensorFlow.
Someone else? Point for the R lovers. So thank you, Maggie, for your presentation. Thank you so much.
So we have our next speaker. He's called Ares Aguilar from Cabify, and he's going to tell a story about how using data to improve customer experience. Please welcome him.
Technical issues. So hello everyone, my name is Ares and I work as a data scientist at Cabify. And today I wanted to talk to you about how is the way that we solve customer problems at Cabify. And I'm going to give you a very specific example that we solved a few months ago. First of all, how it all started. Like always, someone ran into the data science table and said, okay, I have this big problem. And this time, the problem was that customers ordered for a Cabify. We told them that it was 5 minutes away from them. They forgot about it. 5 minutes later, they looked again, and it was 10 minutes away. They canceled the ride, and afterwards, we charged them. So they had to write a complaint, and we have to give them a refund. It was a very painful process. So we had to solve it, and we did it in a very short time. I'm going to tell you how. First of all, the first week, the panic, we had to look at the data to dig to see how deep, how impactful was the problem. And we started looking about our journeys. As you see here, most of them didn't have a refund, and it was a very few percentage that had it. So we thought it was maybe a small problem. But then we looked at those refunds, and half of them were cancellations. So maybe this was somewhat more important than what it seemed. What we did next was to look about the users that did those cancellations. And the way we look at users at Cabify sometimes is looking about the order frequency. If you see here in blue, this is the order frequency for the normal user in Cabify. And in green is the frequency for the users that canceled and got a refund. You can see that they are much better than the normal user. They order much more times a week. But what happened after the refund? You think that this frequency increased, decreased? In red, you can see that all frequency dropped to 0. These were the best users we had, and we were losing them just because of this problem. So we said, okay, we're going to solve it. Let's look at more data. For example, the ETA, the time to arrive of the driver to the rider. But when we looked there was nothing. We were not storing it, so there was nothing we could do. It was Friday, so we went for some beers. And the next Monday, we had to code. I say coding because I am a data scientist, but we really did a simple script that only listened for every cancellation and asked Google about 2 ETAs. The first one is the ETA from the driver to the rider at the higher position, and the other one is the ETA from the driver to the rider, but at cancel position. So we could see exactly what the rider saw in his screen when he canceled. Okay, so we listened at this data for 1 week. And on Friday, we analyzed it and we thought and in terms of 2 very simple features. The first one in the y-axis is the duration of the hire period from the hire to the cancellation. And on the x-axis, you can see the change on ETA that the rider saw. So in negative x means that the driver got closer, and positive x means that the driver moved away from the rider. You can see a straight line on the vertical axis, which is the drivers that were not moving at all. So we designed very simple models, just taking into account these 2 variables. We tried all them, simulated all them, and we found out that roughly 80% of the cancellations were justified for these models. So we picked one. But the next week, when we had to try them, what did we do? We launched an experiment, which was very easy. We simply divided the whole rider population at Cabify in 2 groups. One of them was control, the other one was treatment. And for the treatment group, we simply checked for every cancellation if it was justified. And in the case that it was, we didn't charge for it. We ran this experiment for 3 weeks. And yeah, we were monitoring this every morning, every afternoon. And at the end, we got pretty good results. First of all, we decreased the overall quantity of refunds at Cabify by 35%. Then we decreased the overall time to reply a customer success ticket by 10%. And finally, we increased the customer churn, the overall customer churn by 5%. So thank you very much. If you have.
Thank you, Ares. Please give us the cube in return. Whoa. Any question for us?
Hi, thank you for the talk.
Hi.
How do you know if the cancellation was justified? And so where did the label come from? And if you determine the label by yourself, then why do you need a machine learning model for it?
Yeah. First of all, we don't actually know if it's justified or not. Our customer support team actually looks at every journey and they decide manually if they are justified or not. But we cannot do that, and we are not trying to do that. We are just trying to automatically refund journeys when we are somewhat certain that it's justified. So how do we know that it is? Because we tried a lot of models, different models with these features, but these were not machine learning models. Were very simple models like linear, multiplicative, additive, taking into account error terms, and mostly all of them give the same number of justified rider cancels. So we picked one that was easy to communicate to our user base. But we decided that they were all good because they agreed.
Yes, thank you very much. And I wanted to ask you, how did you define customer churn as the rate of cancellations or number of hired trips, or as a customer stopping completely to use the service?
It's also defined in terms of journey order frequency. It's like the simplest way to say it, it would be like no more journeys after this event. Okay, stop using us. But we don't do that exactly because maybe he didn't saw the receipt that day, he saw it the second day. Or maybe our customer success team worked very well and they recovered so we want to take into account these error terms, and we do it by measuring in terms of frequency.
Okay, great, thank you.
One last question for Ares. So thank you very much, Ares.
Thank you.
So we have now 3 minutes for a small break for you to go to the bathroom in case you drank too much beer. Unfortunately, today you are breaking another record. We ran out of beers and you broke all estimations that we have. So we need to keep improving the model. Sorry for it. Vale. ¿Cómo? No, lo tienes que clicar tú desde mi ordenador. Sí, sí. ¿Quieres que te los clique yo? Yo me quedo aquí y te los voy clicando. Sí. Vale.
Sistema innovativa de Rusia a Ucrania. No sé si a vosotros os interesa contactar.
Sí, de sobra, de sobra. Yep, so you can use this one, it's USB. So I'm introducing Brian Timoney, right? That's him. Hello, Brian, nice to meet you. Very good.
Nice to meet you.
Nice to meet you. Sorry for starting.
No, please. No. God, you have nothing to do with my plate. No, I'm glad you guys started.
So I'll introduce you, Fernando said, as head of data and analytics in Airbus.
Yep. Yeah, exactly.
I'll do a special mention for Fernando for kicking the spirit inside Airbus.
Today? From Munich. US Munich home, but US.
Okay, nice. We are having now people these days kicking off the first event in New York.
Oh yeah.
Yeah.
Nice.
Yeah,
Okay.
hopefully, but it's complex because of all your paranoia with beer and alcohol with underage people.
Oh really?
Yeah, so it's really hard to get people in a
Where's
place
it?
like this.
That's funny.
That is
Where's
not-
it?
Vamos. Please come back. I'm sure there is no more beer, so don't keep looking. Please return to your seats. Thank you very much. So we are going back for business. So now we have the pleasure to have Timothy from sorry, I messed up their names. Brian Timoney he is the head of Airbus in data and analytics. But before I introduce him and I leave him the floor to talk and give us a small introduction about Airbus, I would like to make a special thanks for Fernando. Fernando, he is an employee of Airbus, and he has been a Data.BS fan for a long time. And he was the one moving forward to get Airbus to organize a Data.BS. And so I feel that we have the responsibility to give him a huge round of applause for gathering you all here. Now the floor is yours.
Thank you, and thanks everybody for coming out. So really excited to have the event, and really excited to share a number of the topics that are happening today. So I understand one of the some of the early discussions were around Airbus and the surprise that Airbus actually had data analytics at all. So one thing I wanted to share was a little bit of our journey, right, in 2 minutes as an introduction. So right now, Airbus, we sit on a ton of data, right? And we sit on a ton of data around space, around aeronautics, around imagery. And now we're entering into a phase where we want to take and begin to use that data and bring us into the digital age. We've been manufacturing for a long time, but now digital is where we're going. And this is really important because we sit on a ton of data. And the ability for us to utilize that data and the ability for us to change the marketplace is huge. And so when we look at this in going digital, part of what's really important, and we think about the Airbus story, is that we have airplanes, we have satellites, we have drones. And in all of those, we have the ability to take all of that data, to connect it, and to create a huge story around things that are happening globally. Right? And so if we think about that, not only can this be for things related to Airbus directly, but when we think about what it can do on a global scale in terms of understanding things like weather patterns, disaster patterns, things that have happened materially related to land events, sea events, et cetera, Airbus sits on a bunch of this data. And so the ability for us to take and understand that and to understand what's happening globally, what's happening with patterns globally, and to take and analyze that data to start to create those patterns is a huge move forward. And it's the direction where Airbus is starting to go now. And then lastly, when we think about the world, right? When we think about the maps that we sit on, when we think about the images we sit on, when we think about the sensor data that we sit on top of, the ability to take the patterns, the physical evidence of patterns and imagery that we have, and start to now turn that into actual deep learning and generative models. And so when we think about that, the ability for us to translate all of these things into a true digital footprint for us has a tremendous, tremendous impact. And so that's a little bit of the start of the Airbus journey. We're very early in this journey, but I think it's very exciting. And so that's also why we want to be involved in events like this to start to create a community and start to talk about these events that are taking us forward. So thanks very much for coming and look forward to our next conversations. Okay. So some of you are aware that there is a surprise happening. And so right after the event, we are going to invite everyone to dinner right across the street. So we look forward to seeing you there.
Thank you.
I'm sure you are all happy of this breaking rule of data beers, but thank you so much for the Airbus team. As our next speaker, I'm super happy to announce Ana Laguna. During the day, she's a data scientist in BBVA, Data and Analytics, where we were colleagues. But this data story shows how much a professional data scientist she is, that she took her own data story project during a most important time of her life, probably. So I'll leave her to explain it to you. Please, a huge applause for Ana. Thank you.
Well, hello everybody, and thank you very much for being here this afternoon. Well, as Danny says, I'm Ana Laguna, and I work at BBVA Data and Analytics. And today we will talk about baby crying translation with deep learning, right? Well, as you can figure out, the goal is trying to understand your different baby crying modes. It might be angry or hungry, so it's a good question. Okay. So, well, this is an experiment, a personal project that I developed during my maternity leave, because as you can imagine, I was very bored, right? So, well, just to have some context, some background to understand where this idea comes from. Is this girl crazy? Well, actually, well, when you are pregnant again, everything is happiness. But there are also, well, happiness, hope, illusion, but there are also other feelings like uncertainty, doubt, fear for your baby's health, fear to do not be a good mom or dad, fear to do not understand your baby's needs. And well, these are emotions that you start feeling since the moment you learn you are pregnant with a pregnancy test, right? But this is just the beginning. When the baby arrives, the situation gets even more serious, and there are so many conflicting emotions, right? So there is a very common, for example, a very common postnatal depression called baby blues, and it affects like 60% of women around the world, and actually is due to hormone changes altering producing some chemical alterations in the brain of the women. So the women refuse the baby, feels depressed, feels sad. So, well, a difficult moment, but you are still at the hospital, you are still with doctors, and you can have tips. Everything is under control, right? But then you get home, and the parents are completely alone with a baby. The baby doesn't have instructions like a technological gadget. So, well, the baby starts crying, and all the baby cries seem exactly the same. Oh my God, what am I going to do now? I need a master degree. So, well, with this background, I think that you can understand much better the context of this experiment, right? So I'm not crazy. So at this moment, when I was pregnant, I said, oh my God, I'm going to look for baby crying recognition apps. I think I'm not the only one. And, well, I discovered a Chinese one. But it really had very, very bad reviews. So I say myself, I'm going to create my own baby crying translator. Okay, so first step, I need to collect data, as you can imagine. And I couldn't visit a neonatologist department to record all the babies crying because they will think that this girl is completely crazy. So I start searching online, my first challenge, and I didn't find data at all. So I say, right, I'm going to create my own newborn data set, right? So from the moment the baby was 1 month of life until 4 months of life, I record like 70 audios. Okay, I have my data. I'm super mom. I want to recognize every little cry, every little whining, from a spot coming out to a mosquito bite, everything. But reality is that the newborn cycle, the newborn data daily life is quite all the same all the time, right? So I just can't recognize like 7 baby crying modes. When he's sleepy, when he's hungry, when he needs to puke, he is gassy. The upper change, and others like when he is angry, when he maybe has pain because of baby newborn colics, or when he is fussy, he needs some cuddles, right? So these 7 modes that can be translated into 7 labels for my classification model, right? So, well, wait a second, Danny. So the second challenge, I need to label my own data. As you saw in the previous slide, I didn't start recording my baby until he was 1 month of life, because before we really need to know better each other. And I stopped when he was 4 months of life because the audio frequency really changed. So my data set will be polluted. It was not a newborn anymore. So, well, the labeling, right? Very difficult if I have to do it again. So I label because of the context. My baby was a big eater, so I really knew that every 3 hours he was crying because he was hungry, so it was easy to label, but I couldn't be able to do it again. So this is related with this third challenge, right? Because as he was only crying because of hungry, I didn't have enough versatility in my data. I didn't have enough variance. So I have to go from a multi-class algorithms that I wanted to try before to a binary classification, if the baby hungry or not. So, well, this is funny because here you can see the different audio frequencies before getting them into spectrograms. And as you can see, the hungry one, we're going to play it. Maybe Danny, if you can play it. Well, it has a very clear pattern. Can't hear? Well, the pattern is very clear and has nothing to do with the others. Well, it doesn't work, it doesn't matter. Well, but the idea is this one. The pattern is very clear for angry and has nothing to do with the others. Not working? No. Well, don't worry at all. We see it very clearly in the image. So as I have a very clear pattern, I say, it's like very constant, very clear. There is a pattern. And if you play, for example, the fuzzy one, it's different. Well, it's different. But no, it's okay. Well, angry. Now we have much more energy, for example. Hey. Okay, so well, this is my third challenge. I don't have enough versatility, so I have to go for a binary classification because the baby is a big eater, but he's not crying for any other things. So, well, this is the data, and concerning the algorithms, I just wanted to have fun with deep learning algorithms. So I try with TensorFlow and Keras, and I try multi-layer perceptrons and recurrent and convolutional neural networks. Well, just to have fun, as I told you. So conclusions. Well, the models, well, at the beginning I thought that I didn't have enough data, so the models could be awful, but I was surprised because the results were not that bad. I have good accuracy. So, well, after studying this with expert in deep learning, we realized that even if the data set is very small, when you have like a very clear signal, you don't have to be fear or afraid to test. You can try because maybe it's going to work, right? Anyway, I have a small data set, so I need more data to improve the model, to refine so many details. So I need more multi-level data, of course, because I need to increase the variance of the data set. I need more baby data. That's why I have a new baby on board. And I also need some multicultural babies data because the cry of a baby in Spain has nothing to do with a Japanese baby. So it really depends. It really changes depending on the culture. So with this, I can increase the volume of my data set, and I'm sure I'm gonna solve so many little problems that I found in the experiment. And I also would like to try the clustering for leveling because, as I told you, I really level because of context, but I listen to the audios again and it's complicated. And also trying new apps that appear very recently. Well, I would like really to recommend this app, Chatterbaby, that appeared like, well, 2 years ago, because as I told you, 2 years ago, I didn't find so much research in the area. And recently, there are a good job in the file, right? So, for example, this one, it has been developed by an statistician mom working at the University of California, and she's working with a neonatologist team. So they are really doing a good job. So if you are new parents, you really can try it. And also you can donate your baby cries. And this is important because you can collaborate. Otherwise, you can download my code and try from the tab and try it yourself with your baby cries. So, well, thank you very much. I really hope you have fun.
Thank you so much, Anna. This is really data for social good.
Yeah, of course.
So any questions for Anna?
Hello.
Sí, así.
Yeah. Okay.
Sí, póntelo así. O sea, que te lo pongas delante de la boca.
Vale. Hola. No suena. Hola. Hola. Okay. Okay. So thank you for your presentation. I have one question. I don't know if you actually mentioned that. Did you use the actual audio data, or did you use the images of the spectrograms to?
If I use what?
The audio data, or the actual images of the spectrogram?
No, I use the spectrogram.
The audio.
I transform the audio into a spectrogram.
Okay. Okay, so you use the image data for the.
Yeah, yeah.
Do you search or thought about how likely to succeed it will be if you use the audio data?
No, I didn't try actually. I didn't have time. Maybe the new maternity leave I can try.
Any other questions? No?
I was just wondering about how confident you are about your labeling of your test set.
Sorry, my labeling?
Your labeling of your training data. So you needed this product to translate your baby's cries. That's the idea. But you were relying on your own intuition for labeling your cries. So one time your baby was crying and you marked that as angry. Another time your baby was hungry, you marked it as hungry. But how confident are you that you accurately labeled it?
How often I was recording or labeling?
No, sorry. How did you know?
Because of context. Because when he was in the car, he was like, "Wah!" So I realized, well, when you are mom, you can label. You can, yeah. No, but that's also why I really need to wait until he was 1 month of life, because before I really didn't manage the mothership. So I was leveling because of context.
Okay, and so then if you can tell because of context, when would you need to use this app?
No, I'm not going to create an app. No. It's just for fun. I think.
To help. I thought it was to help people tell if their baby was hungry or hungry. No.
I didn't hear you.
Yo pensaba que era porque necesitas saber si tu bebé tiene hambre o no.
Why I wanted to know?
Yeah, I thought it was a translator. The app is to translate, but it's just for fun.
Yeah, it was just for fun. It was just for fun. No. Okay, maybe I didn't explain it very well. No, it was just for fun. Yeah. And I thought maybe if I have a wonderful algorithm, I can create an app. But with 70 audio, I don't feel like creating an app. So I need you, everybody, to have babies and donate the data for me.
Maybe an app for the father.
No, I thought about grandmas, actually. I thought about grandmas, maybe it could be useful for grandmas. But also this, as the data set is small and it's very specific for my baby, I don't feel like confident creating an app only with a baby, so we need more data. Okay. It's just an experiment for fun.
Someone else, last question?
Sorry? Yeah, I have more data over there, yeah.
So Anna, thank you very much.
Okay, thank you.
So it's time for our last speaker. He's called Juan Carlos Pereira. He's going to talk about how finding hate on Twitter.
Vale. Hello, my name is Juan Carlos Pereira Kohatsu, and today I'm going to present a project I've been working on for 2 years, and it's about finding hate on Twitter. Well, in the last Data Beer where I present, I talk about my final degree project that was about developing a system to detect automatically hate speech on Twitter. However, at the end of the project, I detect that there were a lot of problems. Like, for example, the main problems of this model were, for example, tweets for creating this model were collected in a single day. However, we know that this is a problem because topics and terms change over the time on Twitter. For example, one day we talk about Cifuentes' master thesis, another day we can talk about Barcelona's and Real Madrid match, or maybe we can talk about a guy that blew his nose with the Spanish flag. So another problem that I found was that tweets were labeled by a single person. So at the end, the classifier is going to be biased to this person's point of view.
Finally, the classifier didn't recognize non-alphanumerical characters, and this is a problem because emojis are very important on Twitter's language. So I start a new project for my final master thesis, and the first step is download a great amount of data. Approximately, I download 2 million tweets using the Twitter API from February of 2017 to December of 2017, almost a year. So the next step is to select data. Why selecting data? Well, because it's very difficult to find tweets with hate speech on Twitter. So I built a filter based on more than 500 words. They also contain insults, for example. At the end, 8,710 tweets passed this filter. So this is the data labeling stage. It's a very difficult stage because there is a lot of subjectivity when considering hate speech. So for solving this, I used majority vote. There were 4 labelers, each one from a different background, like for example, psychology, criminology, law, and a housewife. This was my mother. So this was the only person. It's curious because he's the only person that finished the work on time. So at the end, there were 6,000 labeled tweets because we didn't have enough time for labeling all. So 26% didn't contain hate, but 74 didn't. So the next stage consists on cleaning the data. So before I remove non-alphanumerical characters, I decode emojis using a Python library. So you can observe there that also the skin tone is recognized by this library. Also, I create new terms, like for example, hashtags, mentions, or URLs in order to know if they are included in the tweets. For doing this, I use regular expressions. So the next step is the future representation. So for doing this, I use word2vec. So each term is going to be represented as a vector of 200 dimensions. So the idea of word2vec is to obtain the semantic into these vectors. So each tweet is represented as in a matrix form of 200 dimension vectors, in this case, the terms. So the next step is to know if word2vec is working properly. Well, we know that at the end, predicting word2vec consists on predicting different words with a neural network. So we can measure how this neural network predicts using, for example, accuracy. So I obtain 91% accuracy in validation, but this is not the final objective of word2vec. So what I did is to check the nearest neighbor of the different embeddings. For example, the nearest neighbor of rojo is blanco, is amarillo, verde, azul, naranja, and blanco, which are colors, so we can say that is good. But also we can check the nearest neighbor of emojis, like for example, angry red face. So we observe that there are another angry faces, so okay, it's working good. However, we can do more cool things with word2vec, like for example, operating with different vectors in order to obtain new ones. Like for example, to Rey, we can subtract hombre and add mujer. And we obtain a new vector that is close to reina, okay? Same. Seems good. So there are a lot of things that I didn't include in my final master thesis, and now you're going to know why. So for example, at the end, Twitter is a world filled with a lot of topics, bad language, and also a lot of salseo. So why don't we use another words? Like, for example, we can check the nearest neighbor of subnormal. Then we are going to find gilipollas, imbécil, tonto, imbéciles. So why don't we check another word, like, for example, support? And it's not about support vector machines, it's about League of Legends. So we can observe here that we find different characters as Timo, Veigar, or Vayne. But we can go to Korea and observe BTS, which is a Korean group, that we can find also the nearest neighbor that is Blackpink, NCT, or SHINee. So we can do more cool things operating with vectors, like instead of using Rey, why don't we use pene? So we can subtract to pene, hombre, and then add mujer, and we obtain a vector close to teta and vagina. So it seems cool. But also, I'm a YouTuber, so why don't we try YouTuber minus videos, where it says borrego, so para say. So the last stage, once we know that word2vec is working properly, is the classification stage. I use LSTM, which is a recurrent neural network, and MLP, multilayer perceptron, in order to classify. This is the architecture. And the AUC I obtained, because it's an imbalance classification problem, is 0.82. Thank you very much.
Any question for Juan Carlos and his words combinations?
Hola.
Hello.
Hello.
Which is the most popular bad word that you find in your tweets?
Subnormal. It's true, it's true.
And the second one?
Gilipollas, I think. Yeah.
And then did you find any good word in that hate Twitter?
Good words? No.
Thank you very much.
You're welcome.
Any other question?
Hi. So, are you afraid that this kind of applications could be used in some way for censorship? Or, for example, could a government use this kind of algorithm to say, I don't want people tweeting about certain wars or about simply hating each other? So we could,
Well,
they could use this for censorship?
Okay, that is a good question. I developed this tool for the Ministerio of Interior to measure the amount of hate on Twitter, but the idea is just to measure the hate, not to focus in one user. Is to study the society, understand what are the problems of the society.
I really like it. That was so cool.
Thank you.
Did you look at the examples that you got wrong and see if there's a theme? Like, why did you get 20% of them wrong? Like, is there something similar in the ones you got wrong?
Well, I think the irony is like very difficult to understand by the algorithm. Or yes, I think it's the most difficult thing when someone is talking about with irony. Is like, yeah.
Cool.
Thank you, and thank you for your talk. I think it's very interesting. I was wondering if you could detect any kind of trend as, for example, a rise or decrease of or racism or of sexism or any kind of, or maybe more, I don't know, fascist insults, any kind of trend, and if you could use that in a positive way.
Yeah, what we are doing right now is some days we start downloading tweets and use this program, and then I develop in my master thesis another tool to analyze the hate state on Twitter. So yes, we can detect if hate is coming up or down depending on the day. For example, during a football match, the hate against some people, like for example, Catalonia, increases, for example. Yeah.
Yeah, like the label, like the
Yeah.
labels of hate.
Yeah, the idea is to monitoring the hate on Twitter.
Thank you very much, Juan Carlos.
You're welcome.
Applause for him.
We are almost there. So we are almost done. We have a few words before finishing and crossing the street for dinner. But so we need your help from the DataBears organizing team. We need your help at several aspects. Tomorrow you will receive a questionnaire, a feedback questionnaire early in the morning in your email. Please answer it because, believe it or not, it's super useful for us. It's also the way that we have to thank the speakers to give them constructive feedback. Otherwise, we'll detect hate with Josh's tool. Also, if you want to help us, really help us here, feel free. And also, we are starting to embrace this watching your neighbor. So please watch your neighborhood to throw the beer can away. Don't leave any can behind because otherwise we have to go and pick it up. And that way you are helping us. It's only one can for you, and otherwise for us is 300. I would like to ask for another round of applause for the speakers, for Oscar, Maggie, Ares, Ana, and Juan Carlos. Yoshi? So now, because we don't have any more beers, please cross the street after throwing your can. And there we are going to the Airbus accelerator space, and they'll have more beers and dinner for us. and throw it away, please. Thank you.